Okay, so here's our scenario. That's a pool, and it's broken up into 4 sections. There's a section for lapsed swimmers, people who are just swimming back and forth. There's a section for swimming lessons, for people who are learning how to swim. A section for kids, and a section for water therapy. Like anybody who gets injured, they can do some workouts in the water to get better. We need to separate this pool because it wouldn't be good to have kids in the swimming section. They'd all, hit each other. So this pool, we want to find the area of the pool. So let's start with basic stuff. What's the shape of the pool?
Rectangle.
Good. How many?
4.
Okay, some of you see 4 rectangles. Good. Some of you see 2 rectangles. What 2 rectangles do you see? But does that make up the whole thing? Okay. A lot of us see 4. Okay. Are there any other amount of ways you could break that up? Think about that thing we did the other day with the squares. You see 4 rectangles. Is there any other amount of rectangles that make that up if I didn't want to break it up into 4 pieces? How 3? 3 is an option, right? You have this one, and then you could say this one. Right? Does that still make up the whole area? Yeah. What other amount do we see? 8. How do you see 8? Without adding any more lines or breaking it up any more, do you see 8?
All the way across.
So this, like that. How many rectangles is that?
That's 1.
That's just 1, right? So you can break this up a number of ways. How do we find the area of a rectangle? We add the sides. That's area. Anyone want to disagree or agree? If we're in my backyard, what's the area and what's the perimeter? How do you find area?
Multiplying.
You would multiply. We want to multiply what? The length and the width. You're referring to perimeter. If we're in a backyard, the fence would be the perimeter, the area would be the grass. Okay? So we're going to find the area of this whole thing. And we're actually going to do it 3 different ways. So let's notice how they're similar or different. It all depends on how you visualize. We could look at this as 2 rectangles. The swimming area, where people are just swimming, whether it's laps or lessons, and then the water therapy and kids area. Okay. Am I able to find the area of these 2 rectangles if I do what Yandel said and multiply my length times my width? Could I find an area? No. If I multiply length times width, I wouldn't get a value for that. Even if there's a variable, that's okay. I could get a value. Good. Another way, I could find, and a lot of you saw this right away, you saw 4 separate rectangles. You can find the area of each one. If I found the area of this, and the area of this, and the area of this, and the area of that, what would I have to do with the 4 of them to find the total? We would have to add them. Yep, add them all together. Good. What do you think I did, or how many rectangles did I visualize if this was the calculation I was going to do for the area of the pool? What did I do? What did I visualize if that was the expression I came up with? 25 plus x times 8 plus x. What did I think the length was? Or how many rectangles did I see if I was calculating it that way? I saw 1. So what was my length?
25 and x.
Why 25 plus x to represent this length? Why 25 plus x and not just 25x?
Because 25 just represents the swim lessons. And
Okay.
the x variable represents kids area.
So why isn't it this? Why is it 25 plus x? He's right. The 25 represents this portion, and then the x represents this portion. How did we come up with 25 plus x instead of just 25x?
Because x is not part of 25.
Okay, so what did I have to do to find I had to combine them or find the total. This section and this section, that's addition. Same concept for the width. This portion is 8 and this portion is x, which means the whole thing is 8 and x. That's another good word to put in your addition section from your warm-up, just the word and. my age and yours, you would add them together. So now we're going to actually prove that these are equivalent. There's two ways that we can prove that expressions are equivalent. Who remembers the two ways? The first way that we're going to talk about is what's on your quiz, because it's what we've been doing for the past 3 days. What's the first way we can prove that expressions are equivalent? What would I have to do with these three?
Simplify.
Yeah, we're going to simplify. And that's actually what your quiz is going to be on. It's the only thing we've really been doing the last couple days. How can I simplify this? What do you see that needs to go away? What do you see that you need to do? We want to add, right? You're going to add this whole thing and this whole thing. Right? But what can I do before I add them?
You have to take away the parentheses.
I need to somehow get rid of that parentheses. What operation is that parentheses telling me I need to do right now?
Add a and x.
Can I add them any more than this without knowing the value of x? Not yet. What operation is that parentheses showing? Multiplication. So this here, does anyone remember the name of that property that we talked about? No, you're right. The distributive property. So what we're going to do, we're going to distribute the 25. We're going to multiply that, and what else? 25 times x. So 25 times 8, 8 quarters. What do you have if you have 8 quarters? I heard it. 200, good. And then 25 times x. Just 25x, good. And then I'm going to add to that this one. I multiply here x times 8 and x times x. X times 8, 8x. X times x, x to the power of 2. You could say x to the second power, or you could just say x squared. So now, am I done, or is this totally simple? What's the last thing I can do? Add.
And
You can add, but what can you add?
25x plus 8x.
Yes, the only ones I can combine here are this. So we have 200 plus how many x?
33x.
33. Can I combine 33x and an x squared? What do we think? Can I combine the x and the x squared? No, they're actually different values. So I can't. So this is done. This is the most simple form. So this is our goal for the rest. Here, to simplify, it's kind of the same process we did. 25 times 8 is 200. And then from here, we're almost done. Combine your like terms, and you would get 200 plus 33x plus x squared. Again, the exact same thing. We've proven it again. This last one is something you have not seen yet. You will not see it until next year in terms of calculating. This is called, those are polynomials. Poly means many, nomials means terms, so it's many terms. In Algebra 1, you will learn how to multiply and divide polynomials. I don't know if we'll get to it at the end of this year. It only depends on how quickly we get through the 8th grade material. But this is the distributive property again. The difference is you're multiplying this number by everything over here and this number. So it's this, 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 and this. If I do that very quickly, it's 200 plus 25x plus 8x plus x squared. If I simplify, what do you get? The same thing. Did I prove that they are the same? Or in mathematical terms, equivalent? How do you know those three are equivalent? Just by looking at our three simplified expressions.
You could change the x.
I could, but right now, without even doing another calculation, how do I know that this and this and this are equivalent?
Because they have x.
x squared.
Because they are all of the same.
They're the exact same. Yeah, I simplified them and they are all the exact same, which means they are the same value. So now let's do one other way to prove, because without simplifying, the other way you could prove is to substitute in a value. If x was 10, what's the value or area of the pool? If we know instead of just x, that value of x is now 10, what's the area of the pool? What would I do? Which one would you use? Which expression, since we know they're all the same, would you use to find the area if you know that x is 10? The first one, the second one, or the third one? Whichever one you choose, try it. If x is 10, find the area of the pool. Everyone should be calculating this in your notebook. If x is 10, what's the area of the pool? X is 10. Think about which expression might be easier for you to do. We're not just going to sit here for 86 minutes. You have to do something, or you won't be this high. Ooh, I like that. So make sure your calculations are correct, and then what you have to do to find your total. So now what do you have to do with these two? That's perfect. You got the right numbers there. Now what would you do with those two? Try to do that and see what you come up with. Why subtract? Why did you subtract? These look great. That's actually really good. The way you multiply that, that's like multiplying a polynomial. We'll have to do that next year. Now, what I love is that as I'm walking around, and I want you all to keep trying to finish that because it's good practice. All of you are using different expressions. All three have been used, which is fantastic because it's your choice. You don't actually have just one way to find the value. Does anyone want to share which one, now you don't have to give your answer, but which expression you used and why?
The third one.
The third one? Why'd you use that one?
Because you just needed to add 10 to you just needed change x to 10.
If I change x to 10, this becomes pretty straightforward. It becomes 35 times 18. And for some of us, that may have been faster than to go through the process in other expressions. Did anyone use a different one? I mean, I know you did. Which one did you use?
I did 3, but I used 1.
You tried 1 as well. So you substituted in here, you would have had 25 times 18 plus 10 times
18.
18. That's another option. Anyone use the middle one? In looking at all three of them, I really liked the bottom one, but then when I thought about it more, I probably would have used this one only because the number was 10. And I know like this gets very intimidating, a number times itself, but I know that 10 times 10 is 100. I know that one just right in my head. So here, I'm already given the 200, and then I'm going to, at the end, add 100. And I can do 8 times 10 pretty easily, and I can do 25 times 10 pretty easily. So then in the end, I would have just had to have added them. Okay, now when I first did it, I went right to 35 times 18. The difference is, for me, my strength isn't multiplying large numbers. So I found a way using a different expression to not have to do that. This one I didn't really multiply crazy because I can multiply almost anything by 10 in my head. So when I add everything together, or solve 35 times 18, or do the expression at the top, what was your final value? 630. If you were off, it's okay. We're still just getting used to doing calculations. It's a little bit, you become rusty if you haven't done that. But notice there's multiple ways. If you like multiplying, then you can go right to that bottom way. If you prefer to just do some quick multiplication and then add stuff together, the middle one would be a good option, and the top one's kind of a combination of the two. Would I have gotten 630 with all three expressions? Yes, because we already had proven that they were equivalent. Exactly. Perfect. Okay, so we're not going to answer this as we just did. We are going to do a DOL quiz. Does anyone have questions about equivalent expressions before we start? There are 2 questions on your quiz. You're just going to have to write an expression and then simplify it. Okay. On a sheet of paper, whatever sheet you want. Actually, no. On the back of your DOL sheet, can I see your DOL anyway? So here, on the back, you're going to do it here. If you don't do great, it's not a big deal because you can do it again. But this is going to be like the first grade that goes in the grade book, and it's going to kind of summarize what you know from this week. Okay? You can cross into Friday if you need to. You're not doing a DOL tomorrow, so you can use this whole side. So if you want to do the first question on Thursday and the second question on Friday, you can do that. Okay. Do me a favor, make sure your names are on the top, even though they're on the other side. It'll be easier for me when I'm going through. When you are done, it can go in the DOL bin just like you normally would, and then you can try and start, because you'll have time, or finish an assignment that you started yesterday. You can take a look at your next assignment. Next week, when we actually learn like brand new material, there are a lot more assignments to associate with our learning targets. Oops. Really? For example, our first learning target has, where is this? Where is everything? I am recording right now. Oh, there it is.